In this video, we're going to solve a particular problem which appeared in JEE Advance 2019. So here it is given that the notation AP in a bracket A comma D is represented actually AP series with first term A and common difference D, and D is always greater than 0. Now we need to find out the intersection of the set, similar kind of set, which are given as AP 1, 3, 2, 5, 3, 7. Okay, so basically we need to find out that, or we have to find each and every element of AP 13, AP 25, and AP 37, and find the common points, and then it is given that that particular set is also follow a arithmetic progression, and then we have to compare and find out the first term and the common difference, and then the remaining is straightforward. We have to find a plus. That's the problem. So let's go ahead and solve the problem. So as we know that APAD is a set containing that AP terms with first term A and common difference D, right? So that's why, right, we also consider a set S, right? That obviously that determination of that all intersection. So to find out the intersection of all those things, we need to find out separately that all the APs, right? So first AP 13. Now, in this particular AP13, what is our first term? Our first term is actually given as 1, and the common difference is D. So we consider it as A is 1 and D is equal to 3. So now, it obviously, what is the general term? General term is actually the first term, A1 plus n minus 1D. So therefore, here it will be, I just write AM, the general term, or the mth term is equal to 1 plus 3 into multiplied by m minus 1. So if we simplify it, we get it as 3m minus 2. Okay, that's it. Now, if we go ahead and find AP25, right, that obviously gives us a series or a arithmetic progression with first term is 2 and the common difference is 5. So therefore, the general term, or here we take the nth term, right, is actually Bn is 2 plus n minus 1 into 5, which gives me that 5n minus 3. And for the last one, that AP37, it gives us the general term, or here I take that pth term, that is 7p minus 4. So basically, we try to obtain, right, the general term of these things, right? Now here we consider different terms, right? M, N, P. Okay, why? Because if we use all our A, B, N, and C, N, right, it may create a confusion. So that's why I use different index notation. Okay, that's it. Let's go ahead. So now we consider a set S which represents the intersection of these three sets or three AP series, right? Therefore, right, what is the elements of S? So S will be a particular set containing all the elements in the form of X, such that X will be equal to 3m minus 2, or it can be expressed in the form of 5n minus 3, or it can be expressed in the form of 7p minus 4. So therefore, there should exist some integer, positive integer m, n, and p, so that, right, if we substitute that m and p in the expression of 3m minus 2, 5n minus 3, and 7p minus 4, will get the equal values, and those values of x need to be the member of the set S. Okay, that's it. So now our job is to find out the elements of the set. Let's go ahead. So now, first we take, right, the 3m minus 2 is equal to 5n minus 3. That first two term, right, we just forcefully take it as equal. So therefore, if we try to calculate the value of n is equal to 3m plus 1 divided by 5. Now it is obvious that n must be integer, m is must be an integer. So therefore, as n is an integer, so therefore we need to find out some m, positive m, or in such a positive integer m, such that 3m plus 1 is divisible by 5. Then only n will be integer, right? That's it. So here, right, as 3m plus 1 is divisible by 5, so therefore 3m plus 1 can be takes, right, 5, 10, 15, 20, 30, 35, and so on and so forth, right? So basically we just write down all the numbers divisible by 5. Now here those terms are actually in infinite, so we just write down first few terms and just proceed. Okay, that's it. Now we need to calculate the value of n. So what is the value of 3m? It will be 4, 9, 14, 19, 24, 29, and so on, right? So that basically we are calculating the or subtracting one from for each and every numbers, right, in the 3m plus 1. Now we'll divide it by 3 to get the value of m. So m starts from 3, 8, 13, 18, and so on, right? Now see that why I take that 3, 8, 13, and 18, and we left all the other values. Because see that if I divide 4 by 3, it is not an integer. 14 by 3 is not an integer. So I just write down only those elements, right, for m, which gives, right, m as an integer, right? So therefore, if n is an integer, that should imply that, right, m should contain the value m from 3 to 18. So these values, right? Now observe that, right? It contains a pattern, right? So what is that pattern? So M will follow a AP series with first term 3 and the common difference is 5. Okay, that's it. So let's go ahead. You see that it's an AP series with first term 3 and common difference 5. Just keep it as aside because if it's required. Okay, that's it. Now we take that 3m minus 2 and 7p minus 4 because that relation is also need to be equal. So here if we solve for p is equal to 3m plus 2 and divided by 7. So here p is an integer, so therefore we need to find out such m such that 3m plus 2 now divisible by 7. So therefore here 3m plus 2 will take the form, right, 7, 14, 21, 28, 35, and so on, right? And if I try to calculate, right, that 3m, we have to subtract 2 from each and every element, right? So let's go ahead and subtract that. So here we get 5, 12, 19, 26, 33, and so on. Okay, that's it. And if I calculate the value of m by dividing by 3, we just write down only those cases where m is integer. So that's why it's 12, 33, 54. Okay, that's it. So now we imply that if p is also integer, so m should take the value which is 4, 11, 18, 25. Now here also you see that here m takes an AP series, right, where first term is 4 and common difference is 7. Let's go ahead. Now notice that, right, that as m in both cases, right, for the case of that n and p cases, right, that they follow AP series, right? So therefore, right, we can easily write down some few more terms in the case of n because maybe it is required, right? Why? Because see that to find the resulting intersection set, right, we need some elements, at least two elements, because then only we can find out the common difference, right? That's it. So therefore, we can go ahead and write down few more integers, right? So here we can see that, right? If we take the intersection, if I take the common terms, right? Here the common terms is only 18. So if I take that m value, okay, in any of the expression, we calculate the element in x, but only one element. So the first element can be obtained, not the other one, okay, which we talk about. So now we take, right, some more term in those AP things, right? So for the first case, right, we consider some more terms. So we just complete the series. So see that 3, 8, 18, 23, 28, and so on. For the case of m, next one is 4, 11, 8, 18, 25. So therefore, it will be 25 plus 7, so 32, 39, and so on, so forth, right? So we complete that as well. Now we can easily identify that 18 is common and 53 is common, right? Because these two terms are actually existed or common in the term of m. So therefore, m will be 18 and 53. We should not go ahead more because 2m is obtained. Now we can easily find the common difference. So therefore, right, we can find our set S will be on the form of 3m minus 2, where m will be 18, 53, and so on and so forth. What will be the next? I don't care, right? Because it's not required for this particular problem. So therefore, right, our elements in the set will be 52 and 157, right? So the first two term is obtained. Now it is already given that, right, the resulting sequence, right, or the set will be an AP. If it is not an AP, right, so then we need some more terms, right? Why? Because in that particular problem, right, we have to identify is it follow the AP, right? But in this case, it's not required. So that's why 2 is more than sufficient. So therefore, as it is given that is AP, so here the first term is 52A, and the common difference is 157 minus 52, which gives us 105. So therefore, A and D will be 52 and 105 in this particular case. So therefore, for us, right, A plus D is equal to 157. And hence, for this particular problem, right, 157 is the correct answer. And that's it. Now here see that, right? Basically this calculation, right, is done with the new form or some other form of calculation which is called modulus calculation. What is mod calculation? That mod calculation states that, right, that if we divide a number by some other number, right? For example, right? For example, if we say that 17 divided by 2, okay? So what will be that? You can see that the remainder is 1. So we can say that, right? 17 is equivalent to 1 under the mod operation 2, okay? So it's a modulus calculation, okay? Not modulus means it's not the absolute value calculation, okay? But it's called mod calculation. Okay, you will learn in later stages. So the problem can be easily solved in that node. Okay, so that particular theorem, if you call, it's called Chinese remainder theorem. Now, using that Chinese remainder theorem, this problem can be solved easily. But that is obviously out of the scope in this particular thing. But obviously, when you remember that in this particular, if something came and you have to solve other problems similarly, right? So therefore, here as the three AP series are given, which is given as the common difference as 3, 5, and 7. So therefore, you can easily write down in some cases, right, the common difference of the intersection of the resulting series, right, will be the LCM of 3, 5, and 7. So if some mode is given, for example, 3, 5, 7, 11, and something, right? So we have to find the LCM of all those common differences. So that will gives us, right, the common difference of the resulting of the intersection sets. Okay, that's a food for thought. Okay, and here, right, only one thing you have to remember that when I say that find the LCM, so in that case, right, that 357 must be co-prime. Okay, so then only the Chinese remainder theorem can be applied straightforward. In some cases, you may apply it, but that you will learn later stages. Okay, that's it. So hope you understood this particular problem. Thank you.